Welcome to a lesson with Dr. Powell. Let's take a look at the centroid of a triangle. But let's start with a basic example. When we're looking at something like this. Let's do that way. There we go. Okay, we have a triangle, a right triangle even, where we put the hypotenuse on the origin. And this triangle is going to have a slope. Okay, so let's suppose that the height of this triangle, okay, so this side right here, let's just call this, H and let's call that L. Okay, so let's go for it. What we're gonna do is we're gonna think of this line as being y is equal to H over Lx, just the slope, um, given, so it's gonna just be y equals H over L times X is this line right here. And to find the X coordinate, X bar, what we do is we just take 1 over the total area, which would be H times L over 2. So you'd actually get a 2 up here, H times L. And then that's multiplied by the integral that goes from 0 to L of, you're finding the average of the X value. So X is a function, then times dm. So, or your little change of mass or area right here. It's like a rectangle. And that's simply going to be, well, the function at X. So that's going to be the height right there times the dx. So H over L, X is the height, and then times dx. So well, H and L are constants, so we can pull them out. H's will cancel, you have an L squared down there, so you get 2 over L squared integral 0 to L of X squared dx. And that's going to be 2 over L squared X cubed over 3, 0 to L. And notice that we're going to get 2/3 L. That means that 2/3 of the way from here down right here is we're going to have is where the X bar is going to be located, or the centroid. The centroid is going to be somewhere over here, so that much further. And this way, it's going to be 1/3. We can just take this as a general rule that at least perpendicularly, if you just went perpendicular from your base, you're always going to be 1/3 away. And similarly, you could just look this way. Actually, this probably should be lowered because we want to be 1/3. Yeah, so 1/3 of the way from here up to the top as well, going that way. So X bar, Y bar is going to be 1/3 of the way from the bit from a base going perpendicularly, and base we're going perpendicularly that way. And that's how you can find the centroid of any triangle. Now let's use this idea to look at a triangle. Let's just take any triangle like this at all. Okay, so let's suppose that we have suppose we have coordinates. Suppose this is 1 comma 2, say, and suppose that this is maybe this is comma 3, and maybe we've come over I don't know, maybe it's 5, and maybe up here that's why don't we just make it 5 and maybe 4, say. Okay, so we have a triangle like this, and how are you going to find the centroid of it? It's defined between these points like this. So what we could do is we could just think about things perpendicularly, but let's think about X and Y only. I mean, we could split this up in a couple different ways. For one, if we want to do X bar, let's do X bar first. We just draw a line that comes down here. Then all of a sudden, we have a triangle that perpendicularly from its base has a height. going that way. And we have another triangle right here, perpendicularly from its base as a height that goes up here. So the height of this one from base going this way, so we're dealing with this triangle right here, not the right triangle, but this one right here. Notice that actually we could straighten this out in a picture. You could just kind of, think about a triangle as being lots of little, made of lots of little line segments. You could just shift all the line segments over and you still have the same area. In fact, you still have the same distribution. And so you still have the same center of mass if you just kind of straighten this into a right triangle. So really the height is what's important here. And so X bar is going to be 1/3 of the way over here and 1/3 of the way over there for each triangle. And then we're going to take a weighted average of those X bars to get our final X bar, just using this 1/3 trick. Okay, so first of all, see X value is 4 here and X value is 1 here. So we have 3. That's really nice because 1/3 of the way over here from the base will be 1 over. And so it looks like X bar over here is actually going to be 3. Okay, that's X bar. What is this X bar value? 1/3 of the way that way. Well, this distance right here from 4 to 5 is 1. So, so it's going to be, 1/3 past 4, which is 13. Let's see, yeah, 13/3. Okay, so now we're going to take a weighted average of these two ideas. All right. So I guess for that one, we kind of need, I guess we would need to know what this is, because we need to know what the area of each triangle is. So this is just kind of a geometry type thing, I suppose. So we know the height, we just need to know that base. This base value is going to be the same for both of these triangles. So base times height and then times a half. So we got to figure out what that is. Well, we can from slopes if we want to, I suppose. So let's see. Let's go over this way. Let's see. The slope, we know for every 4 we go over, we go up 1, right? So 4, we got 1. So it's like the slope is like 1/4. Okay, so that means for every for every 4 we go over, we have a difference of 1. Okay, so if our run is 1, then our rise would be a 4th, right? So maybe from here, so go over, so every 1, you rise a 4th. Okay, so so that means we're going to drop. So this y value right here drops a 4th down from this y value, which is 3, and we're dropping down 1. So it's just a quarter less than 3, which a quarter less than 3, which would be 11. Let's see, 11/4, right? So 11/4. So this distance, right? So we have this, right? Okay, so this y value would be 11/4. I guess is that what we're trying to do? Okay, or we could think, okay, this is just a 4th bigger. Then we could just think of distances. This is just a 4th this way, and then we're coming up this way, and we're coming up from a y value of 3 to a y value of 5, that's 2. So it's just 2 plus a 4th. So 2 plus a 4th is really what we're looking at. So 9/4 would be that base. Okay. So 9/4 is the base of this triangle. And then we have a height going this way, which we know is 1. So the area of this triangle is going to be 9/4 times 1 divided by 2. So 9/8. So 9/8 is the triangle area associated with that X bar. Now, this one over here, we have, so we have 9, right? Okay, so we have 9, or yeah, that's the area because we multiplied it and then divided by 2. Okay, so then here's the base. The base is 9/4. Multiply it by 3 because it's base times height. So that would be 27 fourths, right? 27/4, but then divide by 2, so 27/8. 27/8 because we're dividing by 2, so that's makes it 4 to the 8. Okay, and then multiply by 3, so 27/8. That is the area associated with that X bar. All right, so how do you find the overall X bar? Well, it's going to be a weighted average. If you take these two guys and add them together, you get, see, 27 plus 9 would be 36 divided by 8. Yeah, 30, yeah, that's right. So 36 divided by 8, which would end up being a 4.5, or I guess, yeah, so we could think about that as, or 9, 9 halves. Okay, 9 halves. Okay, so 9 halves. Okay, so that's the total area of this triangle. And then you think, okay, so then we're going to take fractions. In fact, maybe we could just maybe just think of it as 36/8 for our fractions. That would be fine. So what fraction is this area of the total area? So this area corresponding to this part. So we're going to take 27/8 divided by 36/8, which looks like 27 divided by 36, which looks like yeah, 9/12 or 9 or 3. Yeah, so 3/4. So 3/4. So this area is 3/4 of the total area, which, okay, then consequently this should be 1/4 of the total area. If that's 3/4 of the total area, just by adding together, and you can check. 9/36 is 1/4. That's perfect. Okay, so we have 3/4 and 1/4. Okay, so that tells us that this 3 should have 3/4 of the weight for the X value, and this 13/3 should have 1/4 of the weight for the X value. So to find the final X bar, we simply add the two with their associated weights. 3 receiving 3/4 of the weight, plus 13/3. That's, yeah, 13/3 receiving 1/4 of the weight. And then we add, and so we get 9/4 plus, and then we have 13/12, and then that would be 27 plus 13. So 27 plus 13, so that would be what, 30, no, sorry, 40, 40, 27 plus 13 is 40, 12ths, which is the same as, let's see, 10/3. So 10/3. So X bar should be equal to 10/3. And we did it completely geometrically without even using any integration at all. But we're using, and this example illustrates weighting of averages. If you have a shape here and a shape here, just take the fraction that this shape is of the total and take the fraction this is of the total. Then if you found an X bar for this shape and for this one, you can just simply weight them with those ratio fractions, and you get the ultimate overall X bar in your calculation. Thanks for watching.